All right, folks, here is a video on number 9 from week 21 Wednesday. Okay, so let's explain this real quick over here. Let me see if I can get this side by side with. Okay, so basically we got this equation over here. Okay, and they just converted this into. They converted this right here into decimal form, which you should be able to do in your head because this is basically 4%. Okay, and then this is the derivative. Okay, now this is basically linearization, and this is from. Let me see if I can find it on AP on your on Google Classroom over here for you. I got to label these 7 point. I got to label those a little bit better. I believe it's, let's see where it's at. Here you go, week 12 Tuesday. Okay, linearization, that's where it's from. Okay, yep, linearization. Yeah, I even have a video on it. Okay, so let's go ahead and let's look over here. Where am I at? Okay, so use the line tangent to the graph at t equals 0 to approximate the amount of solid waste of the landfill 3 months later. Okay, so we want to create an equation of a line, okay? And we want to find the slope at t equals 0, okay? So the slope at t equals 0, we literally plug in, okay? Oh, here you go. So let me put it to you. Oh, so basically we have a point over here of 0, comma 1200 based off of these gray highlights, 0, comma 1200. So I am going to basically, from this equation, I'm going to plug in, because this is basically a y coordinate, w of t. So I'm going to plug in 1200 here, okay, and I get 36 from my slope. So we have our point slope form, which is basically y minus y1 equals to m minus k. We have that right there, okay? And we basically have 36 for m, okay? Got 36 for m. Now, and then we have this point over here, 0, comma 1200. So I'm going to put 0 here, 1200 right there. And when we isolate, okay, when we isolate for y, we are basically going to get y equals to 36t plus 1200, okay? So this is our equation for the line. This is, let's say we have a graph. Okay, I'm going to make some graph up, okay? And let's say this is our x and y axis. Okay, that is such a terrible drawing, but you know what I mean. Okay, we have this equation of a line here, okay, that's tangent at x equals to 0 because of that 0, or t equals to 0, and it looks like this. Okay, and let's say this equation represents that, and we want to use this right now. We want to use this red line to estimate what the y coordinate of this dot 3 months later is going to be. Okay, and remember, 3 months later, okay, 3 months later is the same thing as a quarter year. Okay, and because t is in years, we're going to need to convert it to quarter. We're going to need to use this conversion, quarter year. So again, we're trying to find, let me draw this a little bit, scooch that a little bit lower. We're trying to find the y coordinate of this red dot, okay, of this red dot which lies on the blue line, okay. Let me actually use a blue dot here. Let's see how that looks. Okay, yeah, okay, that's better. We're trying to find the y coordinate of this blue dot, okay, and we're going to use the red line to estimate it. Okay, we're going to assume that the y coordinate of this red dot up here, okay, is going to be somewhat close to the y-coordinate of this blue dot. And you can see later on this is going to be overestimation, okay, because the red line is above the blue curve. Okay, in this case, sorry, I shouldn't have said it is going to be an overestimation. I said in this particular example is going to be an overestimation. In this particular really crappy diagram it is. Okay, but we don't know yet over here. Okay, so I just want you to know, so we're going to plug in 1/4 in for t, and that's what they did here. We're going to plug in 1/4 in for t, okay, because we're trying to find out what the y value is going to be a quarter year later. And we are going to get, this is basically 9, so this is going to equal to 1209, okay? That's going to be our estimate, that's going to be the y-coordinate of the red dot, which is an estimation of the y-coordinate of the blue dot, okay? And in the context of this problem, this 1209 is the ton of waste that we are estimating to be using the red line as the estimation, okay? Let's go ahead and go to part B, folks. Okay, so let me scoot this over here. Let's just copy, paste, or cut, delete, move this over, and let's look at part B. Okay, now, I can't remember if there was a diagram for this. Let's look over here. I think there was a diagram that they gave you for this. I should have copied it into the 21 Wednesday. It's taking a lot of time to load. Let's see if I can load it faster here. 21 Wednesday. Let's look and see if they provided you with the diagram over here. They did not. Let me check. Hold on. I swear they had a diagram for this number 9. Huh. I guess not. No problem. So, so we're gonna find the double derivative. Okay. Okay, so let's explain a couple things. Let's explain the first line over here. Okay, so over here, this derivative is going to be greater than 0 when w is greater than 300, obviously, because if w over here is less than 300, this whole thing becomes negative. Okay, this thing becomes negative. Okay, so now let's look right here. They literally just converted to a decimal here. Okay, and we're going to take the double derivative. Okay, so we're going to take the second derivative here. Okay, this becomes that. And you can think of it like this. You can distribute, all right? And you're going to get 0.04 at this stage. When you distribute, you get 0.04 W minus, okay, whatever 0.04 times 300 is. It's going to be like 120 or 12. But it doesn't matter because when you take the derivative of this, okay, it's going to be a derivative of a constant added or subtracted, which means the constant disappears. And then this w becomes w prime over here, okay, because we're taking the derivative of that. So hence this right here. Now, we're going to resubstitute in here. We're going to substitute this back in, okay, for the w prime. So that takes us to this line. And then they just did some algebra over here. We're going to distribute, okay, and we're going to distribute. Let me get some, let's get some stuff out the way over here. They're going to distribute this and get that, okay? And then, now check this out. So we get this right here. We get W is greater than 300. For W is greater than 300, okay? For W is greater than 300, um, W double prime, that's kind of hard to say, is going to be greater than 0, which means it's concave up, okay? Now, by the way, why do we care about this? Okay, because in the beginning it says the increasing function. Increasing means the slope, okay, is always going to be positive. And in order for the slope to always be positive, W needs to be greater than 300. So that is a constraint of this problem, okay? That is a prerequisite, so to speak, for this problem. So in order for this to be true, that must be true because of this. Excuse me, because of this, this must be true. And if this is true, that must be true. Because if you plug in anything less than 300, this becomes, this, which is the single derivative, becomes negative, and we want it to be positive. So in order for this to be true, that's true. In order for this true, that's true. And if this is true, okay, and you plug that into the second derivative is always positive, which means it's concave up, okay, which means it's concave up. The original function is concave up, okay, and if it's concave up and the estimated red line is the estimated red line looks like this, that means the red line is a underestimate, okay. So let's go back to what I drew over here. This drawing was not accurate. It should have looked like this, okay? And that's why I said earlier this drawing was just a crappy drawing. Don't mind it, okay? Or don't think it represents a problem. So it really looks like this, something like that. I made that up but it's a little bit more accurate to the conditions of the problem. So the red line is going to be the tangent line is going to be under this right here because this is concave up based on this fact right here is greater than 0. So the red line's an underestimate, okay? The tangent line's an underestimate, okay? Now let's look at part C now, okay? Let's look at C over here. C is basically what we've been doing a lot, okay? So if you look at C over here, I get this. I'm basically separate. We're basically doing what we've been doing over and over again. I'm going to multiply both sides by dt, take the integral. You can do you're supposed to do a u substitution of w minus 300, okay, and then take the derivative of both sides, isolate for dw, okay, and then you plug in 0, whatever you get, and you get this, you plug in 0, 1200, solve backwards for c, and you get ln of 900 equals to c, okay? And let's see what we got over here. Oh, okay, so that brings us to here. Now, let's just finish this up over here, okay? Now they just plug this 900, ln of 900, in for the c here, and we got this. Now, how do we isolate for w? Because that's ultimately what we want to do, okay? Because it's asking for the particular solution. All right, so what we're gonna do is we're gonna realize that this is log base of e, and we're gonna do circle of logs. Okay, we're gonna do circle of logs. So e to the power of this is gonna equal to that. So as of right now, we get e. Let me type it in bigger. E to the power of 0.04 t plus ln 900 is equal to w minus 300, okay, like that. And then let me make that a base. And remember this property right here, 2 to the power of 3 plus 4 is equal to 2 to the power of 3 times 2 to the power of 4. 1, 2, 3, like this. Okay, and by that same logic, let me put this in red over here. By that same logic right here, we're going to separate this out and put an e at the bottom over here and make this a times, okay? And that's how they got from here, okay, here to here. okay? And then they just added 300 to both sides, okay? Now, by the way, e to the power of log base e, okay, is going to cancel out to a 1, and then 900 converts from an expo, and you can think of the 900 converting from exponent to an actual base. That's a property of log right there, okay? So this 900 becomes a big 900, okay? Because the e in the log base e cancels, and we move the 900 to the front, and that's why we get this, and then we add 300 both sides. Okay, folks, thanks for tuning in. Hopefully that answers your questions.